Hello everyone, my name is Eike Schneiders, and on behalf of my co-authors and myself, I'm going to present our paper entitled Temporal Impact on Cognitive Distraction Detection for Car Drivers Using EEG. Distraction while driving is a major factor for road accidents, and it is estimated that roughly 25% of all road accidents in the US happen due to driver distraction, making the detection thereof quite relevant. When talking about driver distraction, it is typically divided into three separate aspects: visual, physical, and cognitive distraction. In this paper, we only focused on the last one, namely the cognitive distraction. Due to time limitations, I'm just briefly mentioning two related works that our paper was inspired by. First, Sunleitner et al., who investigated the impact of auditory distractor tasks on reaction time while driving. Further, they used EEG in order to classify cognitive distraction and alert states with an accuracy of 92%. And secondly, Al-Mahashni et al., who use EEG to predict cognitive distraction in a VR driving simulator. Both show that EEG successfully can be used to identify cognitive states. This led us to our research question. Is the identification of cognitive distraction based on EEG subject to a temporal impact? Here it is important to mention that by the term temporal impact, we refer to the following. Is a cognitive distraction classifier trained on EEG data from day one still usable for future days? In order to investigate this, we developed the DECIDED system, a system for detection of cognitive distraction using electroencephalography for car drivers. The system consisted of three parts: the driving simulator, which was custom developed using Unity 3D. It made use of a 3-monitor setup as illustrated in Figure 1. Furthermore, the EEG helmet, which was a 3D printed Mark IV helmet by OpenBCI. And lastly, a random forest classifier for binary classification of EEG data into cognitive distraction and cognitive focus. To collect data for subject-dependent classification, we conducted a within-subject user study with 8 participants. In contrast to subject-independent classification, the subject-dependent classification only takes basis in the individual user, meaning that the training of the classifier is being performed on the user's personal EEG data. Each participant was driving twice for 30 minutes with 1 week in between. 15 minutes in the focus condition, where the primary task was driving in accordance to the traffic regulations, and 15 minutes in the distraction condition, where we added a secondary distractor task. For the distractor task, we made use of the audiobook approach inspired by Sunleitner et al. We used a counterbalanced study design resulting in 4 groups. 2 test participants drove in each of the 4 conditions, each time for a total of 30 minutes. We classified each day independently, referred to same day 1 and 2 respectively, as well as the combination of the 2 days referred to as between days. For the same day classification, we trained on 70% of the data and tested on 30% of the data for this corresponding day. For day 1, we achieved 97.5% accuracy and demonstrate the reliability of our approach by being able to replicate similar results on day 2. Here we achieved 98.46%. These results are averaged over all 8 test participants. In order to identify the temporal impact, which is what we set out to do, we trained on all data from day 1 and tested on the data from day 2, which was collected 7 days later. Here we achieved an accuracy of 76%, which is a drastic decrease in accuracy. This points at a temporal impact, leading to a decrease of roughly 21% classification accuracy in the here used setting. So, in conclusion, we were able to confirm current research demonstrating EEG's potential for detection of cognitive distraction, and we were able to identify an accuracy decrease with increased time between training and testing data collection. This suggests a temporal impact leading to a reduced accuracy when using EEG data for cognitive state detection. Finally, I want to highlight 2 possibilities for future work. As mentioned, we have chosen the elicitation of cognitive distraction using an audiobook. It could be interesting if the temporal impact would be different if a different method for elicitation, such as math task solving, phone calls, or interaction with a navigational system, was used. And secondly, we tested our system in a controlled virtual environment, meaning the driving simulator. Here it could be interesting to identify if the results achieved could be replicated in the wild. Thank you for your time.